What's something people don't know about the universe? Welcome to Planet Pulse. Come with me on a journey not through space but through time itself. Let's rewind the cosmic clock, all the way back, before the stars, before the galaxies, before there was a before. We arrive at a single point, a point smaller than an atom, yet containing everything. All the energy, all the matter, all the space that would ever exist was compressed into an unimaginably hot, dense state. This was the universe at its very beginning. Then, in a flash, it happened. The Big Bang. It wasn't an explosion in space, it was the explosion space, the beginning of everything we know. From that first fiery moment, the universe began to expand. And it has never stopped. In the first fraction of a second, it swelled from subatomic size to something vaster than you can imagine. It was a searing hot soup of fundamental particles. As it expanded, it cooled. Slowly, patiently, the universe got to work. Gravity, the master sculptor, began to pull matter together. Protons and neutrons formed. Then they captured electrons, creating the first atoms, mostly hydrogen and helium, the building blocks of everything that was to come, including you and me. The expansion wasn't just a thing that happened long ago, it's happening right now, all around us. Think of it like a loaf of raisin bread baking in an oven. As the dough expands, every raisin moves away from every other raisin. From the perspective of any single raisin, all the others seem to be rushing away. That's what's happening in our universe. Galaxies are the raisins, and space-time is the dough. We look out into the cosmos, and we see distant galaxies speeding away from us. The farther away they are, the faster they appear to recede. This is the echo of the Big Bang, the cosmic music of an expanding universe, playing out across billions of years, a grand, unfolding story. For hundreds of thousands of years after the Big Bang, the universe was a foggy, opaque plasma. Light was trapped, bouncing endlessly between particles, like a ball in a cosmic pinball machine. But as the universe cooled and expanded further, atoms formed, and suddenly, light was set free. The cosmos became transparent for the first time. This first light, released some 380,000 years after the beginning, is still traveling through space today. It's called the cosmic microwave background radiation. It is the oldest picture of the universe we will ever have. A faint, ancient glow that fills the entire sky, whispering the story of our cosmic birth. Our universe is vast. It's filled with maybe 2 trillion galaxies, each one a swirling city of billions or even trillions of stars, and around those stars, countless planets, moons, asteroids, and comets. The numbers are so large they defy human comprehension. Yet for all this immensity, there's a limit to what we can see. A boundary. This boundary isn't a wall or a barrier, it's a horizon, the edge of our observable universe. It's the farthest we can possibly see, and the reason for it is simply yet profound. The universe has a birthday. It's about 13.8 billion years old. Since nothing can travel through space faster than light, we can only see objects whose light has had enough time to reach us since the Big Bang. Imagine a ship at sea. The crew can only see as far as the horizon. Beyond that horizon, the ocean continues, but their view is limited by the curvature of the Earth. Our cosmic horizon is similar, but it's a horizon in time, not space. Light from a galaxy 13.8 billion light-years away has been traveling for 13.8 billion years to reach our telescopes. It's a message from the distant past. We're seeing that galaxy not as it is today, but as it was when the universe was just an infant. This sphere of visibility, with us at its center, is our observable universe. It stretches out about 46.5 billion light-years in every direction. You might ask, how can it be 46.5 billion light-years away if the universe is only 13.8 billion years old? It's because the universe itself has been expanding the whole time that light was traveling. The space that the light had to cross has stretched. So, the galaxy that emitted the light 13.8 billion years ago is now much, much farther away. It's a mind-bending concept, but it's a direct consequence of living in an expanding cosmos. Every galaxy in the universe has its own observable universe. An alien astronomer on a planet a billion light-years away would see their own cosmic sphere, with their home at the center. Their sphere would overlap with ours, but they would see parts of the cosmos that are forever hidden from us, beyond our horizon. And we would see parts of the universe they can't. This means the observable universe, the part we can see, is just a small bubble within a potentially much larger, or even infinite, total universe. What lies beyond that edge? That is one of the biggest questions in all of science. When we talk about the edge of the universe, it's easy to picture a cosmic cliff, a place where space-time just stops, but that's not what scientists mean. The edge of our observable universe isn't a physical boundary you could crash into. It's a temporal one. It is the past. When we look at the most distant objects we can see, we are looking at light that has traveled for almost the entire age of the universe. We are, in a very real sense, looking at the dawn of time. The edge is the Big Bang itself, smeared across our entire sky. It's not a place in space, but a moment in time. Imagine standing in the middle of a thick fog. You can only see for a certain distance in every direction. That's your observable world. There's no wall at the edge of your sight, just more fog that your vision can't penetrate. Our cosmic horizon is like that. The fog was the hot, dense plasma of the early universe. The light from that era, the cosmic microwave background, is the oldest light we can detect. It comes to us from every direction, forming the boundary of our vision. Beyond that wall of light, the universe certainly continues, but we can't see it directly. We are looking at the afterglow of creation. So if you could somehow travel instantly to the edge of our observable universe, what would you see? You wouldn't find a sign that says end of the universe. You'd find yourself in a place that looks much like any other part of the cosmos, with galaxies and stars all around. But something would be different. Your view of the universe would have shifted. You would now be at the center of a new observable universe, one that includes vast regions that were previously beyond our sight. Our old home, the Milky Way, would now be on the edge of new horizon, seen as it was in its infancy, 13.8 billion years ago. This reveals a profound truth. There's no center to the universe, or if you prefer, every place is the center. The Big Bang didn't happen at one spot in an empty void. It happened everywhere at once. The entire universe was once a single point, and that point expanded to become all of space. We are inside the Big Bang, living within its expanding fabric. So the question, what is beyond the edge, is the wrong question. The real question is, what is the overall shape and size of the entire cosmos, the part we can see and the part we can't? What if the universe is finite, but has no edge? This sounds like a riddle, but it's a real possibility. Think about the surface of an orange. It has a finite area. You can't wander on it forever, but it has no edge. An ant walking on the orange could travel in what it perceives as a straight line, and without ever hitting a wall, eventually end up right back where it started. The universe could be like that, but in 3 dimensions instead of 2. We call this a closed or positively curved universe. It would be finite in volume, but unbounded. In such a universe, the fabric of space-time itself is curved back on itself, like the surface of a sphere, but in a higher dimension. This shape is called a hypersphere. If you were to embark on a journey in a powerful spaceship, flying in a perfectly straight line, you wouldn't travel forever into an endless void. Instead, after billions upon billions of years, you would find yourself approaching your starting point from the opposite direction. You would have circumnavigated the entire cosmos. It's a staggering thought. The universe could be a cosmic hall of mirrors, endlessly connected to itself. How could we ever know if we live in such a universe? We can't fly a spaceship that far, but we can look for clues in the light from the Big Bang. If the universe is closed and finite like a giant hypersphere, then geometry at the largest scales would be different. For example, the angles of a giant triangle, with sides stretching billions of light years, would add up to more than 180 degrees. Scientists have studied the cosmic microwave background, radiation, for signs of this curvature. They search for patterns and distortions that would reveal the ultimate shape of our cosmic home. So far, our best measurements suggest that the universe is incredibly close to being flat. This means that on the largest scales we can measure, the geometry seems to be the familiar one we learned in school, where parallel lines never meet and the angles of a triangle add up to exactly 180 degrees. This could mean one of 2 things. Either the universe is truly infinitely flat, or it is so mind-bogglingly immense that our observable universe is just a tiny flat-looking patch on a much larger curved surface. Just as the Earth seems flat to us when we stand in a field, the universe might seem flat to us, even if it's ultimately curved. The other possibility, suggested by the flatness we observe, is that the universe is truly infinite. It goes on forever in every direction, no end, no edge, an endless ocean of space, dotted with an infinite number of galaxies, stars, and planets. This is perhaps the most difficult concept for the human mind to grasp. We are used to things that have a beginning and an end, a size and a limit. The idea of something that is limitless, that has no boundary, is both awe-inspiring and deeply unsettling. An infinite cosmos means that the part we can see, our entire observable universe, is just one infinitesimal speck. If the universe is infinite, then it has always been infinite. Even at the moment of the Big Bang, when it was compressed into an infinitely dense state, it was still spatially infinite. Imagine an infinite rubber sheet being stretched. Every part of it stretches, but it remains infinite. This is the picture of the Big Bang in an infinite universe. It wasn't a single point exploding into nothingness. It was an infinitely large space filled with energy that began expanding everywhere at once. Our observable universe is just the region that expanded from one tiny part of that initial infinite state. An infinite universe has profound philosophical implications. If you have an infinite amount of space, and that space is filled with a random distribution of matter and energy, then anything that can happen must happen. And not just once, but an infinite number of times. Somewhere out there, in that endless cosmic expanse, the exact combination of particles that makes up our Earth, our Sun, and even you, must be repeated. Not just once, but over and over again. An infinite number of copies of you, reading these exact words, at this exact moment. It's a humbling, and perhaps unnerving, thought. This isn't just science fiction, it's a logical consequence of an infinite universe with a finite number of ways to arrange matter. Think of it like shuffling a deck of cards. There are many possible combinations, but a finite number of them. If you shuffle the deck an infinite number of times, you are guaranteed to repeat every single possible sequence, infinitely often. The universe is the deck, and the fundamental particles are the cards. In an infinite cosmos, every possible configuration, including the one that makes up our reality, must exist somewhere out there, far beyond our cosmic horizon. Whether the universe is finite or infinite, we know that the fabric of spacetime is not rigid, it is flexible. Massive objects, like stars and galaxies, create dips and curves in spacetime, much like a bowling ball placed on a trampoline. This is the essence of Einstein's theory of general relativity. Gravity is not a force pulling objects together, it is the geometry of spacetime itself, and light, as it travels through the cosmos, must follow these curves. This can lead to some very strange and wonderful effects, providing clues about the universe's ultimate shape. One of these effects is called gravitational lensing. When light from a very distant object, like a quasar, passes by a massive galaxy or cluster of galaxies on its way to us, the gravity of the massive object can bend the light's path. It acts like a lens, a cosmic magnifying glass. This can distort the image of the distant object, stretching it into arcs or even creating multiple images of the same object. Astronomers have seen this many times. We can look at a single quasar and see 2, 4, or even more images of it, arranged around the lensing galaxy. We are literally seeing the same star, in different places, in the sky. Now let's take this idea to its cosmic conclusion. If the universe itself has an overall curvature, if it is finite and unbounded, like the surface of an orange, it could act as the ultimate gravitational lens. Light could travel all the way around the cosmos and come back to us from the opposite direction. This means we might be able to see the same galaxy in two different parts of the sky. One image would be the direct view, and the other would be the ghost image of light that has circumnavigated the entire universe. We would be seeing the same galaxy at two different ages. Astronomers are actively searching for such patterns. They are mapping the positions of galaxies and quasars on a grand scale, looking for telltale repetitions. They are also scrutinizing the cosmic microwave background, the baby picture of the universe. If the universe had a weird shape, like a cosmic donut or some other complex topology, it would leave a specific pattern of hot and cold spots on that ancient light. Finding these patterns would be like discovering the blueprint of creation. So far, the universe has kept its secrets well, but the search continues, pushing the boundaries of our knowledge. Let's return to the staggering idea of an infinite universe. If it truly goes on forever, then the concept of you becomes complicated. The laws of physics are the same everywhere. The types of particles that exist, protons, neutrons, electrons, are the same everywhere. This means there's a finite number of ways these particles can be arranged in any given volume of space. It's an unimaginably large number, but it's not infinite. So if you have an infinite amount of space, those finite arrangements must repeat. Somewhere out there, there's another bubble of space, exactly the same size as our observable universe, where everything is arranged in the exact same way. This is the idea of the multiverse, but not the kind with different physical laws you see in movies. This is a far more straightforward, and perhaps more plausible version. It's a natural outcome of infinite space. Far beyond our cosmic horizon, there would be another solar system, with another Earth, and another version of you. This other you would be living the exact same life, having had the exact same thoughts and experiences. And because the universe is infinite, there wouldn't be just one copy. There would be an infinite number of them, scattered throughout the endless expanse of space. And it doesn't stop there. There would also be worlds where things are almost the same, but not quite. Imagine a universe where everything is identical, except you chose a different breakfast this morning, or a universe where you pursued a different career, or one where that one mistake you regret never happened. In an infinite cosmos, every possible variation, every path not taken, would be played out somewhere. Every decision you've ever made would have a counterpart in another world who made the opposite choice. The cosmic tapestry is woven with every possible story. This idea challenges our sense of uniqueness. It suggests that our lives, our choices, our entire history are not singular events. They are just one version among an infinite ensemble. For some, this is a terrifying thought, a loss of individuality. For others, it's a source of comfort. It means that no triumph is unique, but also that no tragedy is final. It connects us to the cosmos in the most intimate way possible. It suggests that the universe is not just the stage for our story, but the author of every story imaginable. Our existence is part of a grander, infinite pattern. Why do we ask these questions? Why do we build giant telescopes and launch space probes to peer into the darkness? Why do we care if the universe is finite or infinite? It doesn't help us grow more food or cure diseases, but it does something just as important. It feeds a fundamental human need, the need to understand. It's the same curiosity that drove our ancestors to look up at the night sky and wonder, what are those points of light? What is our place among them? This quest is written into our DNA. It is part of what makes us human. The story of cosmology is a story of humility. We once thought we were the center of everything. The Earth was the center, and the sun, moon, and stars revolved around us. Then Copernicus and Galileo showed us that the Earth revolves around the sun. We were not the center of the solar system. Then Harlow Shapley showed us that our sun is just one of hundreds of billions of stars, far from the center of our own Milky Way galaxy. Then, Edwin Hubble showed us that our galaxy is just one of countless others, all rushing away from each other in an expanding universe. With each discovery, our physical position in the cosmos has become less and less special. We live on a typical planet, orbiting a typical star in a typical galaxy, located in no special part of the universe. But this journey of demotion has been accompanied by a journey of empowerment. The same science that showed us our humble place also gave us the tools to understand it. We are not just lost in the cosmos, we are a part of it. We are made of stardust. The carbon in our cells, the iron in our blood, were forged in the fiery hearts of long-dead stars. These big questions about the universe's shape and fate connect us to something larger than ourselves. They remind us that our daily concerns, our triumphs, and our struggles are played out on a tiny stage in a vast cosmic arena. Thinking about these scales of time and space can be a profound, even spiritual experience. It gives us perspective, it unites us. On this small blue dot, we are all in it together. The exploration of the cosmos is not just about finding answers, but about the shared human journey of asking the questions. So, what have we learned on our journey? We've learned that our universe began in an explosive instant and has been expanding ever since. We've learned that our view of this universe is limited by a horizon of time, a wall of light from the dawn of creation. Beyond that horizon, the universe likely continues, perhaps forever. It could be finite and curved back on itself, a place where a straight line leads you back home. Or it could be infinite, an endless sea containing countless variations of our own world, our own lives. We don't have the final answers yet, and that's okay. The pursuit of these answers is a testament to the power of the human intellect and the persistence of our curiosity. We are a species that looks up. We build instruments to see what is invisible to our eyes. We formulate theories to explain what seems incomprehensible, and we test those theories against the reality of the cosmos. We are the universe's way of knowing itself. The atoms within us, forged in stars, have organized themselves into brains capable of pondering their own origin and their ultimate destiny. What a remarkable thing that is. Cosmology teaches us a lesson in humility but also in connection. When we understand that the light from a distant galaxy has traveled for billions of years to reach our eyes, we are touched by the past. When we realize that the matter in our bodies shares a common origin with the stars, we feel a kinship with the cosmos. And when we contemplate the possibility of other worlds and other lives, we are reminded of the preciousness and fragility of our own. These ideas expand not just our knowledge but our perspective. They make our world bigger. The quest to understand the universe is a story that has no end. As long as there are humans, we will continue to ask these questions. We will build better telescopes, devise smarter theories, and push our cosmic horizon ever outward. We may never know for sure if the universe is finite or infinite. We may never see beyond the edge of our observable bubble, but the act of searching, of wondering, of trying to grasp our place in the grand scheme of things, that is what gives our existence meaning. We are explorers on the shores of the cosmic ocean, and the voyage has just begun. Thank you for joining us on this journey with Planet Pulse. Koi. If you enjoyed exploring the universe with us, be sure to subscribe and hit the bell so you never miss an adventure. Until next time, keep looking up.